Kit, hello. Thank you for joining us for the podcast.
Hey, thanks for having me. Great to see
Yep,
you.
great having you here. What we want to talk about today is camera to AI, farm to table approach. Something very interesting emerging in AI field. So Kit, I'll let you introduce yourself first. Introduce your company.
So I'm Kit Merker. I'm the CEO at Plainsight, and we're a vision infrastructure company. We help companies that want to bring their data, as you said, from the camera into spreadsheets, and how can they turn that unstructured data from all the hundreds and thousands of cameras out there into data they can put into their ERP systems or CRM systems or various databases. And we take a software-centric approach to that, where we've built the kind of infrastructure that you would use to manage and deploy the whole data supply chain, the vision supply chain for the vision professionals that are building all these really cool vision apps we see every day. And I'm really excited by this mission, and it led us to a very cool thing, which is we open sourced our core technology, which is called OpenFilter, and that's available on GitHub under Apache 2. So it's a very permissive license, and we want to see people build on it and expand it and try it out for different things. But the idea of OpenFilter is that it combines both code and machine learning models into a single framework for building and running computer vision applications, both at the edge and in the cloud and with agentic systems. And the filter concept is an abstraction that we developed inside Plainsight, basically inspired by Instagram and Snapchat, or if you've ever used those apps, you have your camera, you pick a filter app, it gives you a kind of a computer vision app on your phone that gives you, hair on fire or a dog tongue or whatever, But we took that consumer technology concept and we applied it to enterprise cloud computing, and we turned it into this application framework that you can deploy into, Kubernetes in the cloud or onto different edge devices. And it's really a useful way of thinking about computer vision, because normally, the code, the models, and all the data kind of, you have to figure out how to get those coordinated. And so this filter concept really is the heart of what we call VisOps, or vision operations, where you have a single kind of standardized unit of computer vision that you can string together into applications and, compose and create utilities and create different IPs.
Thank you for the overview. So just a couple of words about us as well. So Keymakr, we're a training data preparation company, and we're working with Plainsight to provide the data annotation, and that was a part of the pipeline that deals with the data, deals with taking the data from the camera, processing it, annotating the data, creating the labels, preparing the training data set, and then delivering the training data set to the rest of the pipeline. So that's a very, very interesting collaboration here. So that's a good example, like camera to AI, front to table. I really like this analogy. It's not that easy as it sounds. It's not just putting a camera and having a trained performing model.
It's a really big challenge for end customers, and we work with companies that are doing everything from making food and making salads or burgers or other kinds of food, or maybe they're raising livestock. I mean, speaking of farm to table, and we work with a lot of just sort of transportation companies, logistics. They all have this data supply chain problem, right? Which is, it's not good enough to just, turn on the camera and hope for the best or grab an off the shelf model. You really need this highly curated data. So it's great that Keymakr and Plainsight, we're working together, because I think when we go to these companies, they kind of have an expectation that, the model will just work. It's just, and the accuracy that's required in business is quite high, right? They can't be satisfied with, merely, 1 9 or sometimes even 2 nines of accuracy. They need really high quality. And so that combination of being able to take the data, you provide and then, use it for training, it can really drive a higher level of accuracy and quality. But importantly, being able to also add to the data over time, right? So if you have something that needs to be maybe fine-tuned or augmented or retrained, it's another important use case for having a high-quality data provider.
So what do you, from your experience so far, what do you see right now, the demand, like where is the demand from high-quality data is coming from, and what is considered high-quality data in the first place?
Yeah, great question. I think, the the use cases that are emerging in the market right now for computer vision that we're seeing a lot of action for are definitely around quality control and labor replacement type of use cases is very common. I mean, the sort of top of the pyramid of computer vision, the top is smart cities, self-driving cars, and, anything that runs on your mobile phone. That's kind of like the, well-funded, well-established industries. But as time has moved on, what we've seen is that now those use cases are moving down to the next level. I'll tell you, like, one specific use case that's been coming up over and over and over again is related to order accuracy for food delivery. This is one that we have been seeing just an incredible demand for. And the problem is, like, you order some food and you want an avocado on your salad, and so you pay extra money for that, and then the salad comes to your house and there's no avocado. And so you go on the app and you complain. Well, the question is, like, how do we make sure that the person making that item is reminded, right, and prevented from sending it out? And, the kind of brute force way to look at this, you say, oh, well, I'll just put up, some sort of AI system that'll have a red light or a green light. There's a bunch of techniques that have been tried with scales. But really what we want to do is we want to give that food preparer, that chef, if you will, quick serve chef, we're going to give them a co-pilot, where they're getting not just, they're getting feedback, right? They're getting a nudge toward the right thing, where it says, hey, look, hey, I'm the AI system. I didn't notice this item that was supposed to be included. Maybe you should do something about that, and give them that, still the agency of being a human to, do their best work, but augmented by the AI systems. And I think this is where, you can be very clever with this sort of compromise, but it requires a high quality of data, because if that model for this particular restaurant, it might include ingredients that are proprietary, or, that look a little bit different, or the lighting might be different, et cetera. So you want to be able to take the cameras from the live restaurants in situ and pull that in through the camera into an annotation system, improve the annotation. And then actually what we like to do is actually produce a variety of models that are fine-tuned to different environments, which, in order to do that, you have to have this whole data supply chain, because how can you possibly manage all these artifacts and models and all these different versions? Yep. And so this whole concept of taking that data, feeding it through for annotation, like we're the partner like Keymakr, feeding that into a training system, outputting a variety of target-friendly artifacts that can be deployed to different edge environments and different situations and kind of managed well. That's really the whole concept of what we're seeing as a solution to these kinds of problems.
Yes, actually, that's a very interesting use case. So I'll some projects that we did for the specific use case. I'll just mention what tricky parts were there. So you're talking about avocado, right? Missing avocado. Now, when the footage is made of this bowl or the salad or dish being prepared, like how the camera differentiates between avocado and cucumber, for example, because they kind of look the same, or even the same fruit or vegetable in the category. So many different variations of how it can look like. So for us as humans, it's very easy to see it and understand, like, okay, this is apple, or this is avocado, this is pear. But for the AI, it's like the training data that goes into the training, like how we recognize this, it's extremely important. So here we see, actually, it's for the food aspect specifically, we see the AI kind of dealing easily with simple cases where the objects are well defined, it's not blurry, it's very obvious what the object is. Yep. But the moment there is a little bit of ambiguity, or it's blurred, or let's say it's little parts of the object, not the whole object, or it kind of looks similar, like avocado and cucumber, for example, it's both green. If you cut it into pieces, it's kind of the same. That's where the AI system starting to get problems, or starts to be unsure, and that's where the human input, let's say, basically that's where we come in. Where the human input is very important and valuable at the first place. So we help to train the model, we help to create this high quality data that helps the model to distinguish what exactly is what for those ambiguous or difficult cases. So that's every industry has its own interesting use cases, but it's there. There's no industry that does not have this.
Yeah, that's right. And the way I think about Plainsight's role in this is to help accelerate and automate all the steps between those different parts of the puzzle. So you can imagine a world where humans have to go and, oh, notice that the video is not correct, and then go and email somebody to go and annotate it. And like that whole process can be automated down to, a very small number of steps, which means that you can scale the effort to much larger problems and handle it more efficiently. So that's really where I think things are going now, is we've reached a point where the process is well understood enough that we can start to really accelerate the automation and the delivery, which drives down cost and makes it more accessible for for different businesses that maybe don't have the resources to go train self-driving cars and do this kind of very esoteric or very very valuable but like very expensive solutions. Now, if you're trying to build some quality into your process, your manufacturing process maybe, or you want to see how many cars are lined up at your drive-through, or these other kinds of use cases, those are starting to become much more accessible. And because of that, I think it's going to see a pretty big proliferation of vision. And the number of cameras is only increasing. We see the number of cameras in the world. So you think about like, there's all these cameras on the one side and there's all these AI systems on the other side. Like, how do we connect those two things together? And that's really what I'm most excited about, is how to do that, because it can't be done through brute force. If we just merely deployed a GPU for every camera, let's say, I mean, that would not work. Or if we wanted to connect every camera to cloud, we know that wouldn't work either because of, latency and things like that. And I think right now, so much video is optimized for human consumption. And so the question is, like, I think the big change, right, is how do we optimize video for AI consumption? And that leads to a whole different way of thinking about the infrastructure for how we deliver video. Because, I mean, to be honest, like video for people like you and me to watch, we want to have nice, smooth video. We can see everything because we're having an experience. Yep, but actually, AI doesn't experience video, right? AI is just trying to extract data. And so they don't need all of the redundancy. They need to have an experience watching video, to have an emotional reaction to watching video. We want to have this very precise data experience. And so I think that kind of changes the constraints of the infrastructure. And that's really what inspired us on OpenFilter and these projects, was to actually think about a new way of running this large-scale video infrastructure, where instead of optimizing it for human consumption, it's optimized for robotic or AI consumption. And that really changes the way that you build and design these systems.
So that sounds like super interesting. So now the question is like, how exactly you do that? Like, what's the difference between human consumption and AI consumption? Like, how exactly?
Yeah. So I think the simplest way to think about this is about redundancy. Okay, this is like maybe the simplest thing. But if you think about the actual information that's being carried in a snippet of video, in terms of like, I want to output a spreadsheet, right? I want a JSON file that describes that. You might be able to compress it from a 4K video down to cow, and maybe a few other pieces of metadata, right? Car, right? This is the license plate on that car. It's seven digits. That's an incredible amount of compression. And if you imagine like a 4K video running 24/7. And most of the time, nothing is happening, right? Why do we need to process, send all that data to ChatGPT to let it tell us that nothing's happening? It would be an incredibly expensive, something like $16,000, $17,000 a day to send that much video just for one stream of video at 4K. I mean, just absolutely insane. So then it's like you got to put something in front of it to deduplicate, find regions of interest, run smaller models that are more efficient, run it at the edge so that the video isn't even sent if nothing interesting is happening, and then reserve those higher order AI systems for really the most meaningful and impactful frames of interest and regions of interest where it can accomplish a task. And then everything else you want to delegate down to these lower level objects. Well, the way that we accomplish that is we have this unit, this very small unit of computer vision, the filter, that can do a variety of tasks and can be orchestrated on the fly to reduce the total data that's being processed. So think of filters as also about filtering data. It has kind of a double meaning. So if you think about like filtering the data, that's why our OpenFilter logo is a funnel. You're filtering the data down to the interesting bits. And so you're running, ideally, you're going to run the least expensive analytics on the raw video to then reduce it down to where you have the most interesting information that an AI system can use. And that might be having the AI system operating on a JSON blob instead of on video, because all the information that's needed for the analytics has already been compressed down to structured data. If we can convert video into structured data to pass into ChatGPT. Think of it as like generating a prompt
Yep.
from the video stream.
Yes.
That is a completely different way of operating on this, where we don't have to push this very large, heavy set of data, which in reality is just a stream of RGB values in a
Yes.
matrix, right? We can compress that down to a very small snippet of text. That's really the idea. And so this is a tool set to allow people to do that, so that when they're building these context-aware data pipelines from their camera, from farm to table, from camera to AI, that they can put the right steps in between, which is a design task, right? It's an engineering task to decide what matters to me in this video and how am I going to construct a pipeline for it, and to be able to build that from a catalog of pre-built filters, which allows you to bring together different models. Maybe you need an object detection or an OCR model, or these different pieces. You want to construct that into a data pipeline, and you can use it in the cloud if you're doing archive video or kind of after the fact video for batch workloads, or deploy it at the edge if you're running it on live cameras. But having one kind of artifact, one interface to support computer vision workloads broadly, this gets us to this point where now we're setting up the video to be consumed by AI systems as opposed to being consumed by humans.
What we see on our side, so where we used to receive huge chunks of data, like hundreds or even like millions of frames for processing, and we had to go through and filter for, I would say, semi-manually or more of a human input, like decision-making process. What is interesting, what's not. Right now, the trend is to automate this whole data selection process. And it's a very good trend. It saves a lot of, at least from what we see, it saves a lot of time for everybody. It saves a lot of money, because time equals money. And what we tend to receive right now, it's those edge cases where, like, as you said, the frames of interest, the keyframes where something interesting happened, and process only those instead of investing time in huge streams of video that most of them, like over 99% of them, are not that valuable.
Yeah, I think one of the interesting things you're pointing out here is that the vision workloads that lead into annotation are also very similar to the kinds of vision workloads we use for inference.
Yep.
And by having this kind of holistic view of the whole data lifecycle, right, it means that we can treat preparation of annotation, curation, active selection, active learning, right, pre-annotation, automated pre-annotation, et cetera. You can treat those as also vision applications. And so those can become filters. And so now what we can do is, instead of thinking it's like, oh, well, the goal is all about model inference, it's all about how do I run the model on the camera, we can actually think of the whole life cycle.
What pitfalls do you see in this process? Like, where are the issues? Like, how would you identify those issues before they happen and maybe even prevent them from happening? Like, from your experience with dealing with those pipelines.
Yeah, I think some of the challenges that I see that are the big pitfalls, one is having incredibly high expectations for computer vision. I'll be honest with you, the movies and the big tech demos haven't done us any favors in this industry, because people expect that it's all just going to work and it's all just magic, and the AI can just, let's just point a camera, and if it sees any crime, it'll just tell us, right? There's this kinds of thinking that came from the movie. So that's one thing I spend a lot of time, is sort of tempering expectations and understanding that, like, accuracy is a journey. You're going to have to go through and iterate and improve over time. But also you can design the system holistically to have a lower requirement of accuracy to give you the business results. So I think that's one of the biggest pitfalls that I see. I think, not looking at it kind of iteratively, thinking, oh, I'm just going to train the model once and it's going to work great. Why can't I get a 99.99% accurate model in 2 weeks? I have 300 images. Why doesn't it work? Right? That kind of misunderstanding of the state of the technology and what, garbage in, garbage out. I think that's one of the big pitfalls that I've seen. And then the other big challenge I see is, like, how it will scale, right? How will I be able to take something that maybe worked in a single camera with a single GPU and take it out to 100 or 1,000 or 10,000 locations and not have the cost spiral out of control? And this is I think is another big challenge, is that it looks good in the prototype phase, but the production scaling phase has a lot more challenges than people anticipate. And so that's where being really smart about designing the system up front for repeatable deployments and automation, removing the data toil, removing the operational toil. Having all that kind of built in helps you go from prototype to production. And that needs to be part of it in the beginning. Otherwise, what happens is people go build a prototype and they hit a dead end. They get stuck. They can't go any further. And both for the accuracy problem, because prototypes usually don't express the full range of motion that we see, right? So there's that angle, and then there's the production operational constraints as well. Like, how am I going to deploy updates? How am I going to manage the data? How am I going to get telemetry? How am I going to get the edge devices? How am I going to get the GPUs or the edge inference devices? How am I going to manage all that at scale? Is a huge undertaking in many cases, but it is manageable. It can be done. It just needs, I think, the right partners, and it needs the right mindset, and also the right focus on use cases that will drive business outcomes.
So this is something that we see as well frequently, especially when we receive a project. Let's call it prototype. We receive the prototype project. We create a small scale data set. We assume certain performance in a way. And then when the actual project comes in, when the system is deployed in the market and the real life data starts to come in, or it just goes, it scales up, let's say from 1 camera to 100 cameras, the results and the data are completely different from what was going on in prototype. Right. And maybe sometimes we see like the annotation requirements, the initial annotation requirements that team created for us, they become completely irrelevant the moment we scale, and then the whole project has to be revamped, redesigned, and the whole schema changes, because just like whatever was done on small scale does not reflect what's going on in real life on large scale.
Yeah, that's right. I mean, look, this whole business is about taking the messy reality and trying to funnel it into these systems that are only aware of what we train it on, And so if you don't have a training strategy that covers all of these different cases, you're going to not get the accuracy you want. So having it from day one and understanding that you can't train it and forget it. Actually, you need, it's just like an athlete. They need to constantly be conditioning themselves. They constantly are learning new things and pushing the limits. Well, okay, we have this system. We're going to roll out a new store that's going to have a new set of cameras, going to be seeing new things it's never seen before. And so we have to anticipate that that's going to be the same training life cycle. Now, you might not need as much training because you're already pretty good. You already have good skills for watching the stores or the locations or these types of cameras, or these types of objects. You might have good skills, but you need to fine tune it, you need to refine it. And when exceptions happen, you need to have a strategy, because remediation is the key. If you want to be build resilient systems, you have to have responsiveness built in. And we want to build these systems to be resilient to change. The change is exactly what you're describing, where the change might be environmental. It might be, I didn't ever think that there might be snow on the ground, and like the reflection off the snow is changing the images. That is real world stuff that has happened to me on multiple projects. These are the things you learn when you start working with people on computer vision. You start to encounter all kinds of interesting challenges. But the biggest thing, I think the biggest takeaway for people who are thinking about this right now is you want to make sure you have a strategy for improvement over time. It's not a one and done ever. It's something that if you're going to invest in building these vision systems, which can be incredibly valuable, can really take these businesses to the next level and help your team do a better job, right? They can be more productive, more accurate, reduce their mental load. I mean, there's so many advantages if you can get this working, but it's a journey.
Last question. From your experience so far, because you're working on so many different projects, so many different industries, what you would say, like from things you can share, what was like the most interesting, unexpected use case that you encountered while building those systems?
Well, I would say one of the more adorable ones was that we were counting sheep, which can be very sleepy. It can be very sleepy task. But the thing that was interesting was that there's this sheepdog. This sheepdog would show up and he would run across the tops of the sheep. And it was like running on the backs of the sheep. I'd never seen anything like it before. And of course, our AI model detected the sheepdog. So we were off by one, which wasn't good enough. So we had to train AI to detect the sheep and the sheepdog separately, so we could filter out the sheepdog from the sheep. But I'll tell you, like counting sheep is probably the sleepiest task you could ever imagine.
That's an interesting one.
I would just say if people are interested to get started with computer vision, OpenFilter, it's available and easy. It's got a README and a how-to, and you can get it up and running very quickly. It's at openfilter.io. And if you think that's cool, then you want to take it to the next level, then Plainsight's here to help. But that's a great entry point for people who are either new to vision or are interested in taking their vision project and adding an operational concept to it where they can build and manage and deploy vision apps.
Amazing. Good. Thank you so much.
Thank you. Great
Pleasure
to see you.
having you here.